Welcome to 8.3, proving triangle similarity with side, 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 and side, angle, side. So the theorem side, 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 if you can show all three sides are proportional, which is what we've been doing, then you don't need to show anything about the angles. And then side, angle, side, this is important to make sure that you have a proportion, but you also have to have the included side between, the included angle between the two sides they're saying. So here we have zx. So Zx is to PM, and then you have XY, XY. So here's your ZX and XY, and the angle that makes those has to be the angle that you're talking about when you use side, angle, side. So angle X and angle M have to be the same. Okay. Now let's do this. Determine whether JKL or RST is similar to ABC. So we're wanting to know what is similar to the first triangle. So you have to do, it's basically two problems in one. Okay, so first of all, we notice all the order is the exact same based on what it looks like here. We want ABC, then JKL, and then RST. So they're in the same order, so we can just kind of set these up. So let's check A with the middle triangle. 7 is to 6, as 8 is to 7, as 12 is to 11. Okay, and then you take your handy dandy calculator and you figure out what all those are. So 7 divided by 6 is 1.16 repeating. The 6 is repeating. 8 divided by 7 is 1.14. Stop right there. Those are not the same. So the middle triangle is not similar to ABC. Now try ABC to the last triangle. 7 is to 3.5, which is 2. 8 is to 4, which is 2. And then you have 12 is to 6, which is 2. So yes, by side, 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 triangle ABC is similar to triangle RST. All right, same thing here. We're going to do 16 is to, ABC. Let's make sure we do the right order. ABC and JKL, and then RST. So they've changed all these, all right? So we can't go 16 is to 17.5. So what it is AB is to JK. So we have 16 is to 20, okay? And then we have 14 is BC is to KL, all right? So 14 is to 17.5. So we can check those first. 16 divided by 20 is going to be 0.8, and 14 divided by 17.5 is 0.08. So right there, you have a problem. Let's just verify, make sure I didn't hit a button. 17.5. Nope, that's 0.8. My bad. So yes, 0.8. So that's why we double check. And then the last one, 20 must be to 25. So 20 divided by 25 is going to be 0.8. So yes, by side, 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 those two triangles, triangle ABC is similar to triangle JKL. And check the third one. So AB is to RS. So 16 is to 12. And then you have BC is to ST. So 14 is to 10.5. Let's just go ahead and check those. 16 divided by 12 is 1.3 repeating. And 14 divided by 10.5 is 1.3 repeating. So far, so good. You have to check the third side. So now you do 20. AC is to TR, so 20 is to 16. So 20 divided by 16 is 1.25. So that's why you check everything. So no, they're not similar. Okay, number 3, find the value of x. All right, so if these are similar, which it's saying they are, then the order is important here. DEF, DEF, and XYZ. That's the order that they're going. So we can say 2x minus 1 is to 14. And then we use 5 to 10. 5 to 10. All right. So now we cross multiply. Don't forget that's 10 times the 2x minus 1 as a group. And 5 times 14 is 70. So distribute 20x minus 20 equals 70. Add 20. That's 90. and 20x. I'm sorry, that was just 10, not 20. So we're adding 10. That's 80. Divide by 20, and x equals 4. That's all you need. You don't need to do the other x because x is 4 in both of those. All right. Same thing here. D, E to F, and x to y to z. That's important to note the order. So D to E is 10. That's the same thing as x, y, which is x minus 1. And then we can do EF, which is 8. And that's the same as y, z, which is 4. Cross multiply. And again, that's 8x minus 8. Don't forget to distribute. Add 8, and you get 48 equals 8x. Divide by 8, and x equals 6. All right, moving on. Determine whether the two triangles are similar. If they're similar, write a similarity statement. So make sure you write the statement and find the scale factor. Going B to A. So we're going this direction. So we have, let's do this, E, D, F. And this will be X, W, Y. That's the order that those go in. So ED is 8, and XW is 6. Is that the same thing as DF, 12, and WY is 9? All right, so that's only two sides. We don't have the third side. We could do Pythagorean theorem and get the hypotenuse, but we already have the included angle. So this will be side angle side if we have similarity here. So we have to check that. That's 72. Cross multiply, that's 72. So yes, by side angle side, triangle EDF is similar to triangle XWY. Number 6. So again, what we're looking at is you have the angle here that is the same. And match up your short sides here. So this is going to be ST to R. So triangle ST to R. And so that's going to be the small side K to L to J. K, L, J. So it's important to look at your orders. So 8 is to 10, as 18 is to 24. We already know the angles are the same, so that's good for side angle side. Now the question is it proportional? Okay, so 8 times 24. So you take 8 times 24, and you get 192. And 18 times 10 is 180. So those aren't equal, so these are not proportional. So no. So not by side angle side. Now, we're just going to draw generic triangles here. So we don't know if they're obtuse, acute, or right. We're just drawing generic ones and writing everything down. So it's ABC, and then we have DEF. Okay, so BC is 18, AB is 15, and AC is 12. EF is 12, DE is 10, and DF is 8. So by side, 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 let's prove it. So everything's in the right order. So we're going to go 12 is to 8, as 15 is to 10, as 18 is to 12. And we're just going to divide those out, reduce them. Let's just reduce the first one by 4, and we get 3 halves. Reduce the second one by 5, we get 3 halves. Reduce the third one by 6, and we get 3 halves. So yes, by side, side, side. Oh, we forgot to do scale factor on the last one, but let's do scale factor here. Scale factor is any one of these, and we're getting smaller. So the smaller number needs to be on top. So 2/3 is the scale factor. All right, number 8. Again, just draw generic triangles in the order they tell you, A, B, C, and then D, E, F. And plot everything on there. AB is 10, BC is 16, CA is 20. And DE is 25, EF is 40, and FD is 50. All right, so again, set them all up. 10 to 25, and 16 to 40, and 20 to 50. And reduce. First one by 5, we get 2/5. Second one by 8, we get 2/5. And the third one by 10, we get 2/5. Okay, now we're going ABC to DEF. So we're getting bigger. So the bigger number needs to go on top. So 5/2 is your scale factor. Okay, show that the triangles are similar and write a similarity statement and explain your reasoning. Okay, so number 9. These two lines here are not parallel. 5 and 5.5. We don't really know for sure that they're parallel, but it doesn't look like we can prove that. Let's go ahead and figure out these triangles. So we're going to do GH in the small triangle all the way to HF, which is 20. So 15 is to 20. And then we have 18 is to 24. That was the easy one. And then we have HJ, 16.5, is to the whole side. 16.5 and 5.5 is 22. Okay, so now we're going to go ahead and take 15 divided by 20, and that gives you 0.75. 18 divided by 24, and that's 0.75. And 16.5, divided by 22, and that's 0.75. So yes, they are. So now let's write the similarity statement. Triangle HGJ is similar to triangle HFK. Now number 10. We don't have AB or ED, so we're going to use side, angle, side. That's going to be our reason if these work. So we know angle C is congruent to angle C. That's vertical angles. Okay? And now we match up the sides. So be very careful here. 21 is smaller than 27, and 14 is smaller than 18. That means that 21 and 14 go together. 21 is to 14, as 27 is to 18. Cross multiply. 21 times 18 is 378, and 14 times 27 is 378. So yes. And why are they similar? Side, angle, side. And similarity statement. Triangle ABC, be very careful, is similar to triangle AB, and these are flipped, so it's going to be DEC. So on ABC, this goes DEC. All right, same thing on number 11. We have angles that are the same, so we're going to do side, angle, side. So match small sides to small sides. So 21 is going to go with 35. So 21 is to 35, as 30 is to 50. So this will be side, angle, side if they're true. So 21 times 50 is 1,050, and 30 times 35 is 1,050. So yes, by side, angle, side. Now let's do the right order here. X through the small leg of Y, then to Z. So D through the small leg of J through to G. So that's triangle XYZ is similar to triangle DJG. Number 12. So now we have all three sides. We've got to match up the small sides first. So 12 and 9 go together. 12 is to 9. Then the medium sides, 16 and 12. 16 is to 12. And then the big sides, 24 is to 18. All right. So notice how we did that. 12, 16 to 24. So that's going to be triangle SRQ. And then we have triangle, we went 9, 12, 18, so this way, VUT. Okay, so let's just verify these. Just reduce by 3, we get 4/3. Reduce the middle one by 4, we get 4/3. And the last one by 6, we get 4/3. So yes, they are similar by side, side, side. 13. The shortest side of a triangle, similar to triangle XYZ, is 20 units long. Okay, So the short side's 20th long of the new triangle. So it's bigger because the short side of the XYZ is 10. I apologize for the scratchiness of my voice. Okay, that's 20. Find the other side lengths of the triangle. So we'll call this side A and side B here. So we just set this up. 10 is to 20, as 12 is to A, as 13 is to B. Now look at your scale factor here. You're getting bigger. Your scale factor should be 20 over 10 or 2. So all I have to do is double all these lengths. So A is 24 and B is 26. Or you could do cross multiplication and figure them out. 14, the longest side of a triangle is 39 units long. So the longest side here is 13. So again, this is a bigger triangle. So this is 39. So we find the other lengths. We'll call this A and this B. So let's figure this out. Since we're getting bigger, but let's put the bigger number on top. 39 is to 13. So that scale factor is 3. So if we multiply each of these by 3, we get our answers. So A is 30 and B is 36. Again, you could have done proportions on the last problem. All right, so what's wrong with this problem? So first of all, they're saying that the triangles are congruent by side angle side. Let's check their order first. A to B to C. And then they have P to Q to R. Okay, so 15 is AB. It's the smaller side of the two. Okay, so that means PQ should be the smaller side of the two, and they're not. So you should always check their order. So really, let's go ahead and solve this the correct way. So AB should go with RQ. So this should go the opposite direction. So 15 is to 20, as 18 is to 24. Okay, so let's cross multiply. Take 15 times 24 in your calculator, and you get 360. And 18 times 20 is 360. So yes, that's true, but what they did wrong was the order. That's the only thing they did wrong. They are similar. So triangle ABC is similar to what? Triangle RQP. That's the way it should have been. There's all your answers, just to check everything. And notice they wrote down the correct order there. Okay, good job.